So infinite limits, there are vertical asymptotes. So when we find the limit, it results in either positive infinity or negative infinity, which means it does not exist, but we can say which direction it's going. These are the ones that we get when we have a number divided by 0, right? When we have a number divided by 0, it's not removable. It's a vertical asymptote, and we can say which direction it's going. So let's look at this function. F of x equals 1 over the quantity 1 minus x minus 1 squared. So what is the limit as x approaches 1? Well, if we do a direct substitution here, we get 1 over 0. So I know it's a vertical asymptote, and I can look at the graph and I can say, well, it's going to positive infinity. But I can also say, well, if I look at the limit as x approaches 1 from the left of my function, it's going to positive infinity. And if I look from the right, it's also going to positive infinity. Therefore, they match, and instead of saying does not exist, we can say it's going to positive infinity. That vertical asymptote is going up. Let's look at another function. Negative 1 over x minus 1. If we look at the limit as x goes to 1 for this and we do a direct substitution, I get negative 1 over 0. So we know it's a vertical asymptote. We know the limit doesn't exist. But what else can you tell me about it? If I look coming from the left, it's going up to positive infinity. If I look at it coming from the right, it's going to negative infinity. So that gives me information about what this graph looks like. But if I ask you, in general, what is the limit as x approaches 1 of this thing? They don't match. One's going to positive infinity, one's going to negative, so you would still tell me it does not exist. Even though, technically, both of these do not exist either. It's just that I'm able to give more information about the behavior of the graph than just saying does not exist. All right, so let's look at these functions. We're going to find the vertical asymptotes in the holes. So my first one, what is x not allowed to be? X can't equal negative 1. That's not in the domain of the function. Is there anything I can simplify that with in the numerator? No. So that one's a vertical asymptote. So we're going to say we have a vertical asymptote at x equals negative 1. Okay, our next function, what is x not allowed to be? 1. What else?
0.
It's not allowed to be negative 1 either. Right? My denominator is a difference of squares. So x is not allowed to be plus or minus 1. Are those removable? Can I factor that numerator? No, I cannot. So both of these are vertical asymptotes. Okay, we got the function cotangent x. So we want to know, where do we get vertical asymptotes? That comes from when is the denominator equal to 0, and cotangent is really cosine x over sine x, right? Because tangent is sine over cosine, and cotangent is reciprocal. So we want to know, when is sine equal to 0? So let's go around the unit circle. When's the first time sine equals 0? At 0. Then at pi, when else? 2 pi, keep going. So we would say when x is a multiple of pi, we will get vertical asymptotes. Which makes sense if you remember what cotangent looks like. It's periodic. And its period begins and ends with a vertical asymptote. Okay, let's look at this next function. I've got x squared plus 2x minus 8 over x squared minus 4. So, what is my denominator? What is going to make my denominator equal 0? When x is plus or minus 2, right? It's a difference of squares. But I need to see if they're removable or not. So I've got this polynomial in the numerator. It's a quadratic. I can factor it. What multiplies to negative 8 and adds up to 2? X plus 4 and x minus 2. So my x minus 2's will simplify, which means it's removable. So we have a removable discontinuity, or a hole, at x equals 2, and I couldn't remove the factor x plus 2, so that means we have a vertical asymptote at x equals negative 2. So our infinite limits are going to come from a direct substitution that results in a number over 0. If I plug a 1 into this function, in the numerator I'm going to get 1 minus 3, which is negative 2, over 0 in the denominator. So then we need to look to the left and the right and see what is the behavior. A little bit to the left of 1, let's say 0.9. Now you can type that into your calculator in this function and see if you get a positive or a negative answer. Again, you got to know how to use your calculator. You might make a mistake. The method that I use is to put my function in factored form. So in the numerator, I can factor out an x. That leaves me with x minus 3 all over x minus 1. And then I can take my number 0.9 and see what it would make each of these factors, positive or negative. So if I plug a 0.9 into that factor right there, we get a positive number, right? If I plug a 0.9 into my x minus 3, we're going to get a negative number. If I plug a 0.9 into my denominator, we're going to get a negative number. And a positive times a negative divided by a negative is a positive, right? So this is going to positive infinity. If we look from the right, I need a number a little bit more than 1. So let's say 1.1. If I plug 1.1 into this x, that's a positive number. If I plug 1.1 into the x minus 3, negative number. If I plug it into the denominator, we get a positive. So this one, positive times a negative divided by a positive, would be a negative number. It's going to negative infinity. Okay, so my method here is to do the direct substitution and see that I have a number over 0. Then I look and see to the left and the right of it, would it be a negative number or a positive number? That's how I determine. I know it's either going to positive or negative infinity by the fact I got a number divided by 0. Then I'm testing just to see, would I get a negative or a positive? Okay, so let's look at some other functions and see what happens. This next one, if I plug x equals 0 in here, I get 1 plus 1 over 0. Now that 1 over 0 is either going to positive or negative infinity. We have to decide. But compared to positive or negative infinity, does that 1 matter? So we're not looking at this 1 anymore, because it doesn't matter compared to infinity. But we are looking at this term. Now, if I pick a number a little to the left of 0, let's go with negative 0.1, what happens when I plug it in there? It's going to be positive because I'm squaring it, right? And if I pick a number more than 0, it's also going to be positive. So when I see that this is squared, I don't have to do the limit from the left and the right. Nothing's going to make that denominator negative. So this is always going to be positive over positive. This one's going to positive infinity from both directions. All right, let's look at our next one. The limit as x approaches 1 from the left of x squared plus 1 over cotangent of pi x. So that's going to be cotangent of pi when we plug in. And I don't know what cotangent is, because I know sine and cosine off my unit circle. So I'm going to rewrite this in terms of sine and cosine. And cotangent is the reciprocal of tangent, right? So we've got 1 over cotangent, so what we really have is tangent. So that means I'm going to get a sine of pi x in my numerator and a cosine of pi x in my denominator. When I plug a 1 into this thing, I'm going to get 1 squared plus 1 is 2. sine of pi, what's sine of pi? 0 over cosine of pi. What's cosine of pi?
1.
It's -1, but does it matter? We got 0 divided by a number. So this one's 0. Does it matter that I was coming from the left? No, because I got a finite number, which means the left and the right match.
So that's continuous.
Limit as x approaches 0 from the left of x squared plus 1 over x. Well, if I do a direct substitution, I get 0 plus 1 over 0. And we're coming from the left, so like -0.1, which means we have a positive over a negative. So coming from the left, this thing is going to negative infinity. All right, limit as x approaches 0 from the right of 3 times the natural log of x. Well, I can't direct substitute 0 into natural log of x. You type that in your calculator, you're going to get an error. Because 0 is not in the domain of natural log of x. If I graphed the natural log of x, it does this. It has a vertical asymptote at 0. However, if I know what the graph looks like, if we're coming from the right, where is it going? It's going to negative infinity. If I asked you coming from the left, what would you tell me? Does my function exist to the left of 0? No. So that would be it does not exist because it's not in the domain of the function. It just doesn't exist over there. Now, if you didn't know what the graph looked like, for one, you could use your graphing calculator to graph it, but two, you could plug in 3 times natural log of 0.1 and see that you get a large negative number, or 0.001, something like that. Okay, the limit as x approaches 8 from the left of e to the x over the quantity x minus 8 cubed. If we substitute in there, we get e to the 8 over 0 cubed. So what's that look like on a number line? Coming from the left of 8, we can plug in 7.9. My numerator is always going to be 0 because e raised to any power, it's not always going to be 0, is always going to be positive because e raised to any power is positive. E is a number. It's 2.71 something. I raise that to any power, I get a positive. If I plug 7.9 into the denominator, we're going to get a negative, and then we cube a negative, we still get a negative. So that one's going to negative infinity. Okay, the next one, the limit as x approaches negative 3 from the left of x plus 4 over x squared plus x minus 6. In the numerator, we would get a 1. But in the denominator, I'm going to get 9 minus 3 minus 6, that's 0. So we've got a number over 0. So I want to put this in factored form so that I can see which of the factors are positive and negative. So my numerator will still be x plus 4. My denominator, what multiplies negative 6 and adds up to 1?
3 and 2.
I'll get x plus 3 and x minus 2. which means this function has two vertical asymptotes because I can't remove them, right? But we're concerned with -3 from the left. What's the number to the left of -3?
-3.1.
-3.1. Okay, if we plug -3.1 into each of these factors, in the numerator, I'm going to get a positive number. For my x plus 3, I will get a negative number. And for my x minus 2, well, we've got a negative number minus 2. That's still going to be a negative number. So this thing is going to positive infinity.